Hello everyone, Dogs here, back with another video. Welcome back to the AI gaming series. I didn't expect anywhere near the performance of the last video. Thank you all so much. Last episode we got the environment fully set up, we got everything installed, and got a test working properly. I saw in the comments, quite a common theme, was that the terminal was too small. So in the description of the last video, there is all the commands that I ran in the command prompt, the links of where you can download everything, and the code. Hallo Duksche, vielen Dank fürs Zuschauen. Seht am 20. Geshenen Regionen meines Kanals. Also, market weiter so. Hallo Nederlanders, niet bedeling bedeeld maar jullie strijen samen met Canada voor de laatste plaats in de topperigors. Vanaf nu zal ik bij elk video de Belangrijkste regio's bekijken en het einde zal waarschijnlijk niet gebeuren, maar toch probeer hoger te komen. Ni hao quan kan le xiang yigi diao yo zhong wen zimu de shippin de wen shenge shi ge ni de ganze nin de guan kan. Zai zeng xili jeshu shi renjan shobao yongyu liang zidu de gojia jiang yi wuso yu hao judi zihide. Casual hint hint. In this episode, we'll be choosing the use for our AI, figuring out the architecture of the AI's brain, and getting the AI working in a theoretical environment. I'll be breaking it down into 3 tasks. 1. Choosing our use. Some things to note when choosing the use for our AI are that it can be as complicated as you want, but the more complicated, the slower it will run, the slower it will train, and the more resources it will consume. It also shouldn't be too simple, otherwise what's the point of making it? Some examples for things that hit this balance are Snake, the game that's nearly as old as that banana sitting in the bottom of your old school bag in the attic, the Chrome Dinosaur game, or music creation. I'll be choosing the Chrome Dinosaur game for my AI, just because it will be fast to train and run. Number 2. Figuring out the architecture of the AI's brain. Now that we have a purpose in life of our newborn, we need to figure out its brain. The architecture of the brain will be different for different purposes. For example, image recognition would need more middle neurons in the first row than a Snake AI. I'll be choosing about 6 inputs for mine, which will be is it on the ground, its Y level, the distance to the next cactus, the height of the next cactus, the distance to the next pterodactyl, and the height of the next pterodactyl. I'll be choosing 2 layers of middle neurons, with 6 neurons in the first layer, and 4 neurons in the second layer. The logic here is that in the first layer, the AI will be able to sort out its information, and see what info needs to be bundled together. Then in the second layer, it will group them even more, and it will pick the right move for that. I'd recommend not overcomplicating it with a heap of middle neurons, but to keep it to fewer. The exception to this rule is if you have a grid or an image that has multiple layers to it. For example, RGB, the head, the body, and the apple of a snake board, stuff like that. If you got that, then I'd recommend the first middle layer having the same amount of neurons as the base image, if it wasn't multi-layered. For the third part, we'll be getting the AI working in a theoretical environment. We'll be picking up where we left off with our code. What we've got here so far is just getting the output of a network that we've created. We're going to be actually making our neural network for our AI. We're going to put in the amount of inputs that we have decided on. For me that is 6, and I'll be having 2 outputs for up and down. So if you're like me and need random inputs, because you're not using a grid or image or something, then what we're going to do is np.random.uniform. This function just creates a bunch of random numbers for us. So first we want the inputs to be between 0 and 1.00001. The amount of zeros doesn't really matter, it's just saying you want it to be within 0, want it to be either 0, to be 1, or somewhere in between. Then we put in inputs to tell it, hey, this is how many we want. So if you have an image that you're trying to make, like RGB, then since we're putting the inputs to 300 for an example of a 10 by 10 image, the middle would be 100, being the size of the image itself. Then I'd recommend like maybe 3 or 4 layers. So 100, I'd do probably 100 again, then 50. For the inputs, if it's an RGB image, then you would just keep this code here, the random one. If it's not RGB, we can change that back to 100. Then we're going to be doing np.zeros, which just makes an array of zeros, and we're going to add going to make 1 or 2 of them 1, effectively. Do inputs here, then tap in 4, x in range 5. This will give us 5 random inputs to be 1. Then we're also going to be importing random as rand. Import random as rand. Then, so for x in range 5, AI underscore inputs, open square bracket, rand.randint, 0 inputs equals 1. Then we are going to test this, making it print the AI inputs. We'll test. Okay, yes, that did work. Now we have our inputs that are 100 zeros and 5 ones. Just note that this can sometimes like double up on 1 input, or even theoretically like 5 up on 1 input. So there might not be exactly 5, but they'll be close to 5. So that just about wraps it up for this episode. Thank you for watching and have a great day. Bye.